This is one half of the oil cooler. We've mounted it vertically. We've filled this is where the water would go from one end through the brass tube matrix, and on the oil side we can put compressed air, and as I increase the pressure up to about 50-60 psi, you can see the leaking tube. So this is the tube here, the brass tube. These tubes run from one end to the other. The cooling water goes through the tubes and the engine lube oil is on the outside, and this is where the water is getting into the lube oil system when the engine's not running. If we was running the engine, we'd be having oil going into the jacket water, so we need to fit plugs in the end, and this will stop the problem. This is the other half of the oil cooler, and when I turn the air on, it's quite obvious. That one there has got a serious rupture in the brass tube. So what I'm going to do is tap it HBSP and put plugs in both ends. So the next job is to tap it and fit the plugs. So I've now tapped the end of the tube. I'm now going to fit a brass plug with the sealants on. I'll leave the hexagon on for the time being, and when I re-pressure test it and it's okay, we should cut the plug off flush. So this is the oil cooler. Now, because the outside is steel and the tube stack is brass, one end is clamped with a flange on this end, and the other end of the cooler, so it can expand, has an O-ring in here, and it's when you put the end on, the O-ring's compressed to seal the oil from the water, but the tube can still slide in and out as it heats and cools up. So I've now tapped the other end of the leaking tube, and I shall fit the plugs the same, put the cap on, and we'll water test it. So we now have just over 50 psi on the oil side of the cooler. All the tubes are full of water except the one we plugged up, and it's all holding. So obviously this one was the reason we was getting water in the oil system. So I'll leave it for a bit longer, pump it up and let it down a few times to work the tubes, and the problem should have gone away.